Okay, so yesterday we looked at the law of sines and we were able to find missing sides using the law of sines for our oblique triangles when they were angle side or angle side angle. And today we're going to look at using the law of sines if we have this setup right here, which is the ambiguous case. Okay, when we looked at congruent triangles in geometry, we could not prove two triangles congruent with side-side angle because it was the ambiguous case. And we'll talk again in just a second about why that is. But we can have a setup like this and still use the law of sines. We just have to know that it's the ambiguous case, so we have to do a little bit more investigation. Like yesterday, we set it up, we figured it out, boom, there was our answer, and we moved on. So today when we get answers, we're going to have to look at those and make sure that they actually work based on some criteria. Okay, so let's remember what our law of sines is. It's the sine of angle A over little a equals the sine of angle B over little b equals the sine of angle C over little c, or whatever the letters may be, as long as we can set that up correctly. All right. So what makes this the ambiguous case is, so if we have a triangle, so I want you to go ahead and draw this triangle. If I have a triangle that looks something like that, so try and make it at least kind of like mine, otherwise it won't work. And to have side-side angle, that means I have two sides that I know and a non-included angle. So it's different than side angle side. Side angle side would mean that I have this angle right here. So this is side-side angle. If I have that information, like if I just gave you those pieces, like of straws or whatever, and I said, okay, these are the two links that you have, this is the angle you get to make down here, make a triangle, you'd be able to make two different triangles. Because this angle's set, but since this angle right here is not set, I could take this side and swing it in so that it looked like that. And then I would have this big pink triangle, or this triangle right here, which would also have the same two sides in the angle. So you have two different things that you could build with those pieces. So either the big pink one or this green one, and they both have these two sides in this angle. Okay, so that's what makes it the ambiguous case. One of the possible angles for here would be this one, right? So that would be like this other angle in my big pink one. That would be the same measure as that one, because this is an isosceles triangle. In my little green triangle, the other angle would be this one. So tell me, how are these two angles here related? They add up to 180, exactly. So that means that they are what? What's the word for that? Supplementary, very good. And so they're supplementary because they add to 180. What type of angle pair are they? Because that's not supplementary. I mean, those are both right answers than what I wanted. And they are supplementary angles, but then we also had types of angle pairs. Remember we had like alternate interior or vertical, or what were these called? Because they make a line, they're a what pair? Linear pair. So they're a linear pair and they're supplementary and they add to 180, like all that stuff's true. Just want to make sure we're keeping up with our vocabulary there. So let's talk about some of the things we have to pay attention to with our ambiguous case. So it says, watch out. When finding angles, it's possible to have one solution, two solutions, or no solutions. Okay? And that's because we have the ambiguous case. So it says the sine function always has a range between blank and blank. Okay? So it means the value of the sine function has to be between two numbers. So if you think about your unit circle, because although we're not using all the unit circle values and stuff right now, some of the concepts with the unit circle are being applied right now. We still have to know them. So if I have a unit circle, my goodness, that didn't really look like a circle. Pretend that's a circle. When you have these ordered pairs here that are important to us, right, all the way around the circle, is sine the x value or the y value? Y value, okay? So on the unit circle, what's the largest y value you can have on that unit circle? 1, okay? That largest y value is 1. What's the smallest y value? -1, okay? So sine can only, if you take the sine of an angle, the only values you can get are between -1 and 1. I can't get 1.5, I can't get 2, 3, 500, any of that. You can for tangent, but not for sine and cosine. So the sine function always has a range between -1 and 1. That's going to come up and be important for us. Okay, so then angles with a positive sine function, right, are in which quadrants? Which quadrants is sine positive in? Well, we know everything's positive in quadrant 1, right? What other quadrant is sine positive in? 2, very good. Because we can't forget this whole all students take calculus thing. So sine is positive in quadrants 1 and 2. Then it says to find the other possible angles. So when we solve this, we're going to solve the law of sines just like we did yesterday, and the calculator is going to give us one answer. All right, and when it gives us one answer, we need to find the other possible angles. So remember, this would be one of the angles in the triangle, and this would be the other one. These two are congruent because this makes an isosceles triangle. So basically, it's these two angle values. So if the calculator gives me this one, how do I find this one? Subtract it from 180, right? Because they're a linear pair and they're supplementary and all that kind of stuff. So whatever the calculator gives me, I'm going to subtract from 180, and then that gives me my two possibilities. Okay? Then we have to do a little investigation. Then we should also know that in any triangle, if you add up all three of the angles, what do you get? What's the sum of the angles in a triangle? 180. Okay. It's also 180. So these are both 180, but for two different reasons. And then no triangle can have two blank angles. There's actually two answers for this. So you can give me both of them and I'll tell you which one we're really using and why. But think about that. No triangle can have two what angles? Right angles, that is a correct answer. That's not what goes here. I need to reword this sentence. It's not what goes here because we're dealing with oblique triangles, but that is a true statement. So what else can it not have two of? Obtuse, very good. So you're not wrong about the right, but just I didn't word it very well. Okay, everybody good so far? So we need to think about all these things as we go through these questions. One of the things that I failed to do yesterday, and it didn't occur to me until somebody asked me a question in the afternoon, was we didn't do any questions yesterday where you had to draw the triangle. And then there were some of those on Delta Math, which hopefully you were able to figure out just fine. But that was a good question. The question was, does it matter where I put my letters when I draw it? And the answer is no. It does. Yes and no. I don't want to be. So when you label the angles, that doesn't matter. Then you just have to make sure you use the sides correctly, basically. So if we look at number 6, this is going to be triangle ABC. So I'm just going to draw a triangle. Most of the time when I do this, if it's not a right triangle, mine almost always look equilateral, even though this clearly won't be an equilateral triangle, because I don't know when I start exactly what it should look like anyway. And that just makes it easier to label. And I just know that it's not to scale, and my angles may not make sense, and it's fine. So I'm going to put ABC. Now, just for the purposes of the notes, it probably would be easier for you to label yours like mine, just so that when you look back up here, it makes sense. But honestly, if you were doing this on your own and you put A here and B here and C here, it's totally fine. You just have to make sure then that in this case, we're calling them the length of AB, the length of BC, but it may use little a and little b, so just know that little a would go across from big A and things like that. So if yours is labeled differently to begin with, it just means your triangle's turned and you're fine, okay? So then we'll label what we have. Measure of angle A is 60 degrees. The length of AB is 30 inches. The length of BC is 27 inches. And I want the measure of angle C, so I'm going to call that theta. So when you show your work for your Delta Math, one of the things I'm going to be looking for is your triangles being drawn and labeled. So make sure that you are doing that as part of your work for this. So now we're just still working this like we did yesterday. And we're going to set up the law of sine. So 60 goes with 27. Theta goes with 30, because I have two sides in the non-included angle, so this is side-side angle. So anytime you are using the law of sines to find an angle, that's when you have to do this other investigation. If you're finding a side, you're fine. If you're finding an angle, we have to look into some more stuff. Okay, so I'm going to take the sine of 60 over 27 equals the sine of theta over 30. So this time I'm looking for theta, not for an x. So to get the sine of theta by itself, I'm going to multiply both sides by 30. So this will give me 30 times the sine of 60 over 27 equals the sine of theta. So I need to get theta by itself. I cannot do that by dividing by sine because that doesn't make any sense because this isn't multiplication, right? When we're looking for an angle, what do we have to do to get sine away from theta? Inverse, very good. So I'm going to take the sine inverse of both sides. So that means I'll have the sine inverse of 30 times the sine of 60 over 27 equals, now the sine inverse of the sine of theta is just theta. So now I've gotten theta by itself. Now is when you can move to the calculator. Make sure your calculator is in degrees. Again, I don't care which calculator you're using as long as you can find these buttons and make it work. So I'm using the 84. So I'm going to do sine inverse of 30 times the sine of 60 divided by 27. Now remember, we have this number, but then I also need the other possible angle. So I know at least one of the two of Delta Math or Desmos, one of them has an answer key. I think the other one does too. I just forgot to look. So basically I want to take 180 minus that 74, but we never type decimals back in. So I'm going to do 180 on these calculators, answers down here. So I'll do second answer. Oh, no, that would help if I actually did a. So I wanted to do subtract 180 minus second answer. So those are my two possibilities. If you don't have an answer key, honestly, when I use this calculator, I really don't even do that. I would just say, I know I need to subtract it from 180. I'm too lazy to do second answer. So if I just do minus 180 and just know that it's going to be negative and I want the other, then see, I would just know that it's 105 and 74, whatever, just to get the values. But these are the two numbers that we want. So we're going to write those down. So we write down that theta equals 74, oh, that's a 4, dang it. 74.207 degrees and 105.793 degrees. Okay. Now, I don't know that both of those are going to work, so I have to check them. So the way we check them is you take the angle they gave you, 60 degrees, and we're going to add this first angle to it. Now, I don't care about the actual value. So I just know that this is 60 plus 74 something. And all I care about is that value going to be greater than, less than, or equal to 180? So I don't have to type this into a calculator. I don't have to actually find it, but I'm pretty confident that that right there is going to be less than 180. Because what we're checking is, if I do use this for theta, will it work in here? Because if it's not less than 180, I don't even have room for this third angle, and I know I can't have more than 180 in the triangle. You with me on that? So it has to be less than 180, so we have room for angle B. So this one works. So then I take that same 60, and I add it to the second angle, 105 something. And again, that's going to be 165 something, so that's less than 180. So they both work, and I get two angles for this answer. Okay? Any questions at all? Oh, and all right, so let's look at number 7. We're going to draw a triangle. And we'll just do ABC. I'm a creature of habit, so my triangles almost always look the same, and they're labeled the same, and it's fine because we're just trying to make sure we're matching stuff up correctly. Angle C is 89 degrees. The length of AC is 34 meters. The length of AB is 26 meters, and we're looking for angle B. So 89 goes with 26. Theta goes with 34. Also, when they look a little bit more equilateral, it's way easier to tell which angle goes with which side. The weird obtuse ones are the ones that can be confusing. All right, so we're going to do law of sines. So this is the sine of 89 over 26 equals the sine of theta over 34. So again, I multiply both sides by 34. So 34 times the sine of 89 over 26 equals the sine of theta. So now that I've got the sine of theta by itself, I take the sine inverse of both sides. So I'll have the sine inverse of 34 times the sine of 89. Oh, somebody's knocking. They knocked very light. You knocked very light. What are you doing? Oh, great. Okay. Well, I'm glad you're here. Okay, that equals theta. So go ahead and type that in. Get your answers for theta. Okay, so how many of you have typed it in and then double checked yourself? Does it give you something you were expecting? Probably not, right? Probably gives you something that makes you go, crap, what did I do wrong? Right? That's what it does to me. So if you're using an 84 type calculator, then this is what I get, error for domain, or you might get like a syntax error or some weird error, something about an error on calculators like this. If you are using the Desmos calculator, then, so this is what we just typed in, then you get undefined, okay? If you are using the, oh, I don't know if I can get there without, hang on a second. If you're using the Delta Math calculator, then you get the little 3 dots, okay? Which that one really makes me question things. But, because, I mean, at least tell me something, don't just give me 3 dots. But if you get those when you're typing stuff in, yes, double check yourself, because it is possible you type something in wrong, okay? That is possible that's the reason why, so you just double check that, did I really do that right? And the answer is supposed to be undefined. So we're getting what we're supposed to get. It's not what you expected to get, but you could also get it by accidentally typing something in wrong. So then I typed in just the inside part of this because I wanted you to see what it was. And it is 1.3079. So the reason we are getting an error is because we can only take the sine inverse of something between -1 and 1. So this is greater than 1. I don't get to take the sine inverse of that because it doesn't make any sense. You with me on that? So that's why you're getting that. Like this triangle isn't even going to work itself. Okay. So although I wouldn't expect this on like your assignment or whatever, I want you to write on your notes so you remember why it works this way. We're going to write sine inverse of 1.3074, just so you can remember why we're putting no solution when we put that. It's because we're trying to take the sine inverse of something greater than 1. You can't be greater than 1 or less than -1. So when you do that, it's undefined or error or 3 dots, or I don't know what else you might get on a different one, but it's not going to work, basically. So your answer is no solution. And it's no solution because of a sign domain error, basically. Okay, we okay with that? So what that means is if I gave you that 26 length stick and a 34-inch stick, and I told you that angle has to be 89, you're not even going to be able to make a triangle with it. It's just not even going to work. Like, it won't match up. Okay? Everybody okay so far? All righty. Let's look at the next one then. Number 8. So draw your triangle. So go ahead and draw and label. You should be able to do that without me, I hope. And clearly my triangle's not to scale because that's 102 degrees. Totally fine. AC is 21 yards. AB is 24 yards. One. Angle B. Okay. So once I have it all set up, I can go ahead and do my law of sine. So I'm going to take the sine of 102 over 24 equals the sine of theta over 21. And multiply both sides by 21, so 21 times the sine of 102 over 24 equals the sine of theta. Then I take the sine inverse. That equals theta. And then that's when I can move to the calculator. So go ahead and find your two possibilities here. Those are the two values I got. Make sure you're getting those values too and not just copying mine down. Let me know if you're having issues with the calculator or whatever. We all good with those numbers? So then I don't get to just box that and move on. I got to check them, right? So I take the original angle that they gave me, 102. I'm going to add it to this first one, so that's going to be plus 58 something. So that'll give me 160 something. That's less than 180, so that one's good. If I take 102 and I add it to 121 something, that's way more than 180, so that's a big fat no. So this value doesn't work, and in this case, I only have one angle. Okay, by the nature of the triangle. Because how I showed you, you swing that other side in, you can't always swing it depending on what the lengths and whatever are. Okay. Any questions at all? All right, so then I want you to do number 9 on your own, 100%, draw, label, set up. I will come back up here and start working it. I'm going to go take attendance first, but I'm going to pause the video, so if you're watching the video, pause it and work the problem and then come back. So I don't know if I've given you enough time or not, but that's what I ended up with. So if you've checked yourself on number 9, and you agree with me, you don't have any questions, you can go ahead and start working on number 10. I'll leave number 9 up here for a minute because I think some of y'all are still working on it, which is fine. But go ahead and start working on number 10. Please let me know if you have any questions. If you're stuck, you're not sure what to do or where to go with it or whatever. Do you know what's going on? You picked up kind of? The second, okay. So to get this number right here, once you got this in your calculator, right? So we have to find the other possibility, and so you subtract this from 180 to get this one. Okay. And if you want, since you missed the first part, just watch the very first part of the video, like before you start working examples, and I'll kind of explain to you why. Okay. All right. Everybody else good? All right. I'm going to start working on number 10 then. I've given you enough time or not, but let me know if you have any questions. Are we all good, do you think? Making sense? Okay. I know we're doing lots of examples today, but that's because different things can happen, and I want to make sure that you've kind of seen a little bit of everything. So we are going to do number 11. Let's go ahead and draw and label number 11 and try and get it set up, and then we'll talk about it. So this is one a little bit different than the others? Yeah, because on the other ones, the angle that we were looking for was across from a side that we have. We're looking for angle C. We don't have the side across from that. And I can't find it like with Pythagorean theorem because this is not a right triangle. But I do have enough information to find angle A, even though they didn't ask us for angle A. But if I find angle A, can I use that to find angle C? Okay, so basically that's what we're going to have to do. Now, remember, theta is like our go-to x for a missing angle. After we've used theta, then your next go-to is usually alpha, and it looks like a fat Jesus fish. That's makes you think like he ran into a wall or something and puffed up. Or maybe if he was a puffer fish, maybe it would look like that. I don't know. But so then I can go ahead and set up my law of sines. I can take the sine of 125 over 21. That's equal to the sine of alpha over 24. Okay, so then we're going to do the exact same thing as we did before. We have to completely solve for alpha just like we had on the other problems. Then we can use that to find theta. Okay, so go ahead and go through your work to get alpha. So even though we found two values for alpha, neither one of them work, right? So we end up marking them both out, and our answer here is no solution. But it's for a different reason than it was on the first, right? Now, that's no solution for alpha. Okay, let's think about this for a second. We were looking for theta. But if alpha has no solution, is it possible to find theta? No. Okay, so the first time we got no solution, it was because of a sign domain error. Like we couldn't take the sign inverse of that value. It didn't make any sense. Here we're getting no solution because neither one of the angles work because it makes it more than 180. Let's say that it did work, that one of them did work. If this first angle worked, then I'm not done. I'd have to add it to 125, subtract from 180 to get the theta I'm actually looking for, right? If they both work, then I would have to subtract them both. Basically, I'd get two answers for theta because I have two answers for alpha. Does that make sense to you? Any questions at all? We're all good? So hopefully the law of sines is pretty simple. Like getting through the process is good, but then on this one, because it's the ambiguous case, you have to have a little bit more thought and do a little bit more investigation before you can answer your question. Okay, are we all good? All right, so that was pretty long, I know. Most lessons aren't this long, but I wanted to make sure we kind of hit every little thing there. All right.